Hi, and welcome to lesson 8.3 for pre-calculus. So today we're going to learn about the inverse of a square matrix. So what is an inverse matrix? The inverse matrix is very special. It is the matrix such that if we were to multiply any matrix by its inverse matrix, the resultant matrix will be an identity matrix. So for example, we have matrix A and matrix B here. If we multiply these two matrices together, we're going to get the identity matrix. And remember, your identity matrix is going to be the matrix with 1 down the diagonals and zeros everywhere else. So let's see if these actually result in an identity matrix. We're going to find out if they're inverses of each other. So we're going to multiply matrix A by matrix B. So let's go ahead and write that up here. Okay, so we want to multiply these two matrices together. So when we do this, we get -1 times 1, which is -1, plus 2 times 1, which is 2. And our second entry will be -1 times -2, so that gives us 2, plus 2 times a -1, so -2. Next row, we get -1 times 1, which is a -1, plus 1 times 1, which is 1. And finally, we get -1 times -2, which is 2, plus 1 times a -1, so plus a -1. All right, when we do our math, we get 2 minus 1 is 1, 2 minus 2 is 0, -1 plus 1 is 0, and 2 minus 1 is 1. So we see that we do get the identity matrix. So therefore, A and B are inverses of each other. And specifically, we can write B as A to the -1. This represents that it is the inverse of matrix A when you write the -1 right here. Okay, so we've found out how to find or how to show that they're inverses of each other. Now we're going to go into actually solving for an inverse. So we have the following matrix: 1, 2, 3, 7. We need to find its inverse. So we're going to set up an equation like the one that we just have popped up here. The reason why we're going to set this up is that we are going to transform this part of our matrix into the identity matrix. And whatever happens to this part of it, that will be our inverse of our matrix. So let's go ahead and transform this into the identity matrix. So the first thing that we want is a 1 in our upper left-hand corner. We're good. We have that. So we don't need to do anything now. Now we need to get our 3 to be a 0. So in order to do that, we're going to take our row 2 and we're going to subtract 3 of row 1 from it. So now we get the matrix where we keep our top row the same. Okay, so now we want this plus a -3 of this. So let's write those numbers above. So we have -3, -3 times 2 is going to give me -6. -3 times 1 is going to give me -3, and that will be a 0. Okay, so 3 minus 3 is 0. 7 minus 6 is 1. 0 minus 3 is going to give me a -3, and 1 plus 0 is 1. Okay, so we're almost at our identity matrix. Now we want to get this number right here to become a 0. We've got 1s down our diagonal, so we're good. We've got our 0 here, so now this needs to become a 0. So we're going to take and subtract 2 times of our second row and add it to this. So we want row 1 minus 2 of row 2. Really quickly, if we write our numbers, that means that this will be a 0. -2 times 0 is 0, -2 times 1 is a -2, -2 times -3 is +6, and -2 times 1 is a -2. So now we've got 1 plus 0 is 1, 2 minus 2 is 0, 1 plus 6 is 7, and 0 minus 2 is -2. And we didn't change our bottom row, so we're just going to copy that back down. Okay, so now we have found our inverse of our original matrix. So So if we were to say that this matrix equals A inverse is going to be the matrix 7, -2, -3, 1. That is the inverse. And we can test this out by multiplying these two together. So let's go ahead and do that. So we've got 1, 2, 3, 7. And we're going to multiply that to what we found as a matrix. So 7, -2, -3, 1. And let's see what we get. So we get 7 minus 6. So 7 minus 6 is 1. Now we get -2 plus 2. So that's 0. Now we have 21 minus 21. That gives us a 0. And -6 plus 7 gives us a 1. Perfect. We have the inverse, so we are good. So that's how you're going to solve inverse matrices. We have one more way to solve it, and we're going to learn this on the next slide. Okay, so the method that we used on the previous slide can be used to find the inverse of any type of square matrix that has an inverse. So a 2 by 2, a 3 by 3, a 4 by 4, a 10 by 10, so on and so forth. However, there is one other method that we can use specifically for a 2 by 2 matrix, and that's if we find the determinant of a matrix. So the determinant of a matrix can be found with the following formula right here. So if we have a 2 by 2 matrix, and for example we have A, B, C, D, so these are just representing different numbers, we can find its determinant by multiplying AD and subtracting BC from that. So the determinant is going to equal 1 divided by AD minus BC. And then we're going to multiply the determinant to this matrix right here, which is a manipulation of our original matrix. And the way that you get this manipulation is you're going to swap your A and your D, and you're going to make negative your B and your C, so the positions that are in here. So let's take the same example that we had from our previous slide. We want to find the inverse of this matrix using the determinant. So we want to first find the determinant. So we know that our determinant formula is 1 over AD minus BC. So remember, this is going to be the positions that they're in. So our determinant equals 1 divided by 1 times 7 AD, so that's 1 times 7, which is 7, minus BC, which is 2 times 3. So that gives us 6. So our determinant for this particular matrix is 1 over 7 minus 6, which is 1, which equals 1. So our determinant happens to be 1. It doesn't always end up that it's 1. It could be any kind of scalar number. But for this example, it's 1. So now we're going to multiply this scalar to our manipulated matrix. So now let's take our original one and do what it says here. So we've got our swapping of our A and our D. So 7 now is in the first spot, and 1 is where the D used to be. And we're going to make negative our B and our C. So 2 becomes negative, and 3 becomes negative. Or we're changing the sign, I should say. That was probably more appropriate. Okay, so this is our new matrix, and we're going to multiply that times our determinant, which is just 1. So 1 times each of these just equals our matrix 7, -2, -3, 1. And this is your inverse. So again, this only works for a 2 by 2 matrix that has an inverse, but it is an easier way to possibly solve for the matrix. You can also use the way that we did on the previous slide. That works too, but this is just another way to do it. All right, that's it for today. Hope you guys enjoyed this, and have a good one. Bye-bye.